Hello everyone, my name is Salman Baset and I work for IBM. And today I want to tell you about the SPEC Cloud IaaS 2016 benchmark, the first industry standard benchmark to measure the performance of infrastructure as a service clouds like OpenStack. So I'm going to briefly tell you about what is SPEC. SPEC stands for Standard Performance Evaluation Corporation. And then tell you about the benchmark and the type of clouds it can measure, and then what's coming up next in SPEC Cloud. So SPEC Background, anybody who has worked with performance or who is in the performance area knows about well-known SPEC benchmarks such as SPEC CPU or SPEC Java. So SPEC is a non-profit that has been creating these benchmarks for measuring the performance of computer systems. And the cloud subcommittee of SPEC, which I'm the chair, released the first industry standard benchmark, the SPEC Cloud IaaS benchmark in May this year, which can be used and is already being used to measure the performance of infrastructure as a service clouds. So what does this benchmark mean for OpenStack? So as we know from our performance involvement, that measuring cloud performance is difficult. And in particular, measuring OpenStack performance is even more difficult because there are so many configurations options and so many ways in which OpenStack can be deployed. Moreover, there are just too many metrics. How do we compare one cloud to the other? Or even how do we compare one result of one cloud to another result of the same cloud? So SPEC Cloud IaaS 2016 benchmark has been released to measure the performance of IaaS clouds in a measurable, comparable, and a repeatable way. So, OpenStack vendors can use this to measure the performance of their clouds. And I think what can potentially happen, and this is something up in the air, and that before every OpenStack release, the performance, or before every OpenStack summit, the performance of newly released OpenStack distribution can be measured by SPEC Cloud IaaS benchmark, and those results can be potentially announced in the keynotes, etc. And the benchmark measures the scalability and elasticity of the cloud, and having those numbers together with the configuration of the OpenStack that was used to measure the performance could give operators a lot of belief in the new release and whether this release is going to scale and may not have issues that may have been seen in the earlier releases. So, what is cloud? I don't need to preach this, but they are public, private, and hybrid clouds. From a benchmarking perspective, we divide clouds into two types. One is so-called black box clouds, or so-called public clouds, in which the hardware or the cloud stack may not be under the control of the tester. So public clouds are obviously one example. In the white box cloud, which is more of a private cloud, although not hosted private, but really private clouds, in which all the stack is under the control of the tester. And the benchmark can be used to measure the performance of black box or white box clouds or public and private clouds, and can be used to compare the performance across these clouds. So, what are the cloud characteristics? SPEC has worked on that for quite some time. So, we talk about cloud should be elastic, that we should be able to get resources as we want to ramp up or ramp down, and as we're doing the work, the requested resources should be available to the jobs. We also talk about the cloud should be scalable, that the cloud, we can, as our application needs grows, cloud should be able to provide us the resources as our application grows. So these numbers have been abstract, and we've been talking about that. And so what SPEC Cloud has done is that it has quantified these numbers. It has come up with precise definitions for the scalability and for elasticity. So think of this analogy when we talk about SPEC Cloud. Think of an infinitely high mountain. So this is an infinitely high mountain, and think of each step as taking as some amount of time. So initially, when you start climbing the mountain, maybe you take 1 second or maybe 1 minute per 1 second per step. But as you keep going higher, the amount of effort you may have to put in increases. So every step may take maybe 5 seconds or 10 seconds because you're tired. In an ideal cloud, each step should take the same amount of time, so because it is elastic, and you should be able to grow as much as you want because cloud is infinitely scalable. But the reality is that clouds do not have infinite scale. Even public clouds have limits, and obviously private clouds have limits. There are resource limits, there are quotas, and all of that. So what is a good IaaS benchmark? A good IaaS benchmark is the one that provides meaningful, repeatable, and comparable metrics. It can measure cloud elasticity and scalability, not just the application elasticity. It can measure performance of both public and private clouds. It should be able to measure both provisioning as well as runtime performance. So, and at scale, not just one. It should place no restriction on how the cloud is configured. It should allow using of VMs, bare metals, or containers, and allow easy addition of new workloads. So this screenshot is a real result published by Dell, and and this is a result of SPEC Cloud IaaS benchmark that Dell has published. So you can see here is that there is a number called scalability, which is you can basically think of this is a unitless number, and the higher the better. So this is scalability, and it measures the total amount of work done in the cloud. At 20 application instance, each application instance, think of it as a cluster of instances that do some work. So in SPEC Cloud, there are two types of application instances defined: YCSP Cassandra and Hadoop K-means, each having 7 and 6 instances, and multiple of those instances can be started. So in this case, there were 20 application instances that were started. Elasticity is 71%, which means that the amount of that the performance of the cloud at load was 71% to the time when the benchmark put no load on the cloud. The mean instance provisioning time is the time from the provisioning request to the time the VM was available for access on port 22. There are other metrics that are also reported, such as provisioning success and run success. And there is a detailed report that you can go and look at on the SPEC website. As I mentioned, SPEC Cloud has two workloads, YCSP and Cassandra. YCSP has 7 instances, and K-means has 6 instances. And the benchmark has so-called 2 phases. One is the so-called the baseline phase, in which only one application instance of each type is launched. So there is one application instance of YCSP Cassandra comprising 7 instances that I just showed here. And then after that, one application instance of K-means comprising 6 instances is launched. So that's the baseline phase. In the so-called elasticity plus scalability phase, multiple application instances are launched until some limits are reached. These limits could be user specified to control the amount of budget they spend on the cloud, or some stopping conditions could be reached due to some quality of service violations. So I talked about the benchmark phases. So pictorially, the elasticity and scalability phase looks like this. Each box here represents each row represents one application instance. So there is one application instance of K-means, one application of YCSP, and so on and so forth that are added over time. So this increases the load on the cloud. As application instance is created, synthetic data is generated, and then the workload YCSP or Cassandra runs. So each box represents one run, and there are multiple of those runs. And the benchmark stops when a user says that I do not want to provision behind maybe 50 VMs, or the quality of service conditions have reached. Pictorially, this is what a SPEC Cloud benchmark looks like. On the left there is the benchmark harness, and on the right is the cloud under test, where multiple instances are configured. And as I mentioned, that there is no restriction on how an instance is configured, so you can pick up a medium or large instance, or pick up any disk within an instance. But once that choice is made, that choice cannot be changed during the rest of the benchmark. So this is combined with the specific versions of the software that we use for Cassandra and Hadoop, so that when a submitter submits a result, we can be sure that another submitter or another provider is going to run the benchmark under using the same software. So scalability, as I mentioned in the slides, is the total amount of work that could be done by the application instances in the cloud. And elasticity is a measure of how good was the cloud performance relative to the time when benchmark put no load in the cloud. There are other metrics, as I mentioned: mean instance provisioning time, application instance run success, application instance provisioning success, and the date and time on which the elasticity phase of the benchmark was run, so that one can really compare and contrast. For example, especially in public clouds, the time of the day could be important a factor. The benchmark stops when certain stopping conditions are met, and these are some of the ones listed here, such as application VMs failed, or VMs or containers or bare metals failed to provision, or there are any runtime errors, or there are quality of service violations, or the quota set by the cloud provider has reached. There are results published on the SPEC website by some vendors, so you should go and take a look, and you should consider publishing results for SPEC Cloud. And lastly, there are some updates coming to the SPEC Cloud. SPEC Cloud was IaaS 2016 benchmark was released in May, and it's being updated to be compatible with the Newton release, and also it is compatible with many other cloud providers such as AWS, Google, IBM, SoftLayer, Rackspace, or IBM Cloud. And so it's just not specific to one particular cloud, but can be used to measure performance of multiple cloud providers, both control plane as well as data plane. And in future, and there has been some initial discussion on what other standard benchmarks we could create, for example, for object storage or event-based systems, serverless systems. With that, here's the link for the SPEC Cloud benchmark. I encourage you to go there and find out more about this, and I'll be happy